continue with the particular terms of the binomial expansion for a plus b to the power of n. So if we want to find a particular terms from the binomial expansion, we can use the formula here, and r multiply with a to the power of n minus r multiply with b to the power of r. For example, if we have a plus b to the power of 8. For example, if we want to find the third term from the expansion, we can use the formula 8 to a to the power of n minus r, this means 8 minus 2, and b to the power of r, that means b to the power of 2. And we can simplify here. 8c2 is equal to 28 multiplied with a power of 6 and b power of 2. So this will be the third term from the binomial expansion for a plus b to the power of 8. Next example, if we have the same binomial expansion and we want to find the sixth term, and we can use the formula 8, 5. We need to know if you want to find the sixth term, this means here r is going to be 5, because the first term we start with 0. R equal to 0, r equal to 1, 2, 3, 4, and 5. So the sixth term, T1, T2, T3, T4, T5, and T6. So R is going to be 5 here. Now let's find 8C5. So it's equal to 56 a to the power of 3, b to the power of 5. Next example, find the coefficient of y to the power of 5 and x to the power of 6 in the expansion of x plus y to the power of 9. So we compare with general equation here. A is equal to x, b is equal to y, and n is equal to 9. So we use the formula n r a to the power of n minus r multiplied with b to the power of r. The first one, we're going to find the coefficient for y to the power of 5. So let's substitute all value that we have. So n is equal to 9. We have 9r, a is equal to x to the power of 9 minus r multiplied with y to the power of r. So the first one, we want to find y to the power of 5. So it means r is equal to 5. So for y to the power of 5, we have 9, r is equal to 5. So x, 9 minus 5, 4, and y to the power of 5. And from here we can get the coefficient 9c5 is equal to 125. X power 4, y power 5. Okay, so the coefficient is 125. Next, for x to the power of 6. We use the same formula. 9r x to the power of 9 minus r multiply with y to the power of r. So we want x to the power of 6. So from the formula 9 minus r, to get power 6, 9 is minus with 3. So it means r equal to 3. For x to the power of 6, we have 9c3 x to the power of 9 minus 3. You get x power of 6 multiply with y to the power of 3. And you will get 9c3 is equal to 84. X power of 6, y power of 3. And the coefficient for x power of 6 is 84. Let's move on to the next question. Determine the terms independent of x in the following binomial expression. X power of 2 minus 3 over x squared to the power of 10. So we want to find the independent of x. So it means constant, other name for constant value. Constant value or x to the power of 0. Our information here. Okay, so we use the same formula, and r multiply with a to the power of n minus r multiply with b to the power of r. From the binomial expression, a is equal to x squared, b is equal to negative 3 over x squared, and n is equal to 10. So let's substitute the information we have. 10 r x squared to the power of 10 minus r multiply with negative 3 over x squared to the power of r. Now, we want to find the terms that independent of x or constant, and we're going to equal to x to the power of 0. Now we need to find the value of r, or which terms that contain the independent of x. So let's simplify. For x here, we have x to the power of 20 minus 2r multiply. So we're going to use r and x only. So let's separate negative 3 power of r, and we bring x power of 2 above, and we will get x to the power of negative 2 multiply with r here. Okay, so we need to find the value of r first. So we're going to use r. For the coefficient, we leave for second after we get r. And let's simplify the equation. X to the power of 20 minus 2r multiply with x to the power of negative 2r equal to x to the power of 0. And we will get x to the power of 20 minus 4r equal to x power of 0. And we have the same bits for the index. 20 minus 4r equal to 0. 4r equal to 30 and r equal to 5. And from here we know the independent of x is lie on the sixth term, and we can substitute back r into the formula. Okay, so we can simplify the equation here, and we will get 10c5 is equal to 252, and here we will get x power of 10 multiply with negative 3 power of 5, we will get negative 243 multiply with x to the power of negative 10. So x power of 10 and x power of negative 10 can cancel, equal to 1. So we will just multiply 252 with negative 253, and we will get the answer 61,236.